Properties of the periodic table. So you're going to go to this website and you're going to complete the assigned questions. Make sure that you are carefully reading and not just skimming for answers. There's lots of really good information here. So the table of elements that you see on the screen is what the table of elements really looks like when we expand it out. Usually, you're probably used to seeing it looking something more like this. So the difference is these elements here at the bottom get added into this little section on the periodic table. So when you do that, we get a periodic table that looks like this. So you're going to go ahead and answer those questions, and then when you are ready, you can return here. We're going to do some summary, but we are not going to answer every single question. So the first question is asking us to label the main group, the inner and outer transition metals. So the main group is also sometimes called the representative elements, and that's because these elements follow periodic trends very accurately. So some of the transition metals kind of break the trend, but our main group elements always follow our trends. Next, we're looking at some of the different groups and columns on the periodic table. So a family, a group, and a column all mean the same thing. That refers to something that goes up and down. A period, series, and row refer to across, left to right, a horizontal row. Now, some important ones to note here are going to be your alkali metals, your halogens, your noble gases, as well as hydrogen. So some properties here, the alkali metals are going to be very soft metals. You can actually cut them with a knife. They're going to have very low melting points, and they're going to be very, very reactive. So the alkali earth metals are a little bit less extreme than alkali metals. So they're still soft metals with very low melting points, but they're a little bit less reactive and they're a little bit harder. The transition metals. These are the things that most people think of when they think of metals. They think of the transition metals. These are going to be hard metals with very high melting points. They're going to be very dense, and the reactivity of these elements ranges. So some of them are very reactive, and some of them are very stable, very non-reactive. The noble gases, these are going to be in column 18. And these are going to be very stable because they have a full octet of electrons. So noble gases are called noble gases because they tend to not form compounds with other elements. And that's because of their stability, because they already have a full octet of electrons. Halogens, these are very reactive diatomic elements. So diatomic means that there's two of them. So for example, Cl2, Br2, I2, those are all diatomic elements. And the halogens are very reactive as well. And then hydrogen, who doesn't quite fit in and is kind of a weird element compared to the others on the periodic table. It is a diatomic gas, and it can either lose electrons like alkali metals, or it can gain electrons like halogens. Next, we want to identify our metals, nonmetals, and metalloids. So metals make up most of the periodic table, and then on the right side, we have our nonmetals. A quick way to find the metalloids is to draw a little staircase underneath boron. So boron, silicon, germanium, As, Sb, Te, At, all of those elements are going to be our metalloids. Our nonmetals are going to be all the way on the right side of the periodic table. And most of the elements are metals. So let's talk about delocalized bonding. So delocalized bonding is what we see in metals. So the electrons are shared by all atoms. So if we have a metal, like let's say that we have sodium, metals are going to give up an electron. So we'll form Na plus and we'll have one electron as well. So that's where these cations come from. It's these metal atoms that have given up electrons. And now those electrons are floating around in the electron sea. So metals have the properties that they have because of this delocalized bonding. So electricity is just a flow of electrons. Metals already have flowing electrons, so they're going to be really good conductors of both heat and electricity. Metals are malleable because the electrons aren't rigidly locked in place and they can shift without destroying the network of bonds that are holding the metal together. So if you can imagine, if you hit this with a hammer, these guys are just going to slide past and will bend rather than break. And those shiny moving electrons are able to reflect light, so metals are shiny. So metals have this property because of delocalized bonding. When you think of a nonmetal, nonmetals have pretty much all of the opposite properties of metals. So they are poor conductors, they are brittle, and they are dull. So this is all explained by localized bonding. So the electrons are held in place between two atoms. So here I'm showing a bunch of carbon atoms. This is actually the structure for diamond. And each of these lines represents a pair of electrons that is being shared by these two atoms here. So because those electrons are held in one place between the two atoms, there's no flow of electrons. So it means that they're going to be poor conductors of both electricity and heat. They're also going to be brittle. If you were to hit this atom with a hammer, you would break this bond here, and that would cause the substance to fall apart. So shifting around atoms is going to break the bonds that are held with the electrons within the substance. And there's no moving electrons to reflect light, so they're going to be kind of dull. Now, metalloids. These are in between metals and nonmetals, and they have properties that are in between metals and nonmetals. This is because we have a combination of localized and delocalized bonding. So these are very useful as semiconductors. They're good at conducting, but not as well as metals. So that has a lot of applications with computers. Anything that has a microchip in it has some metalloids in it. So you're going to go ahead and complete Journal Write 1. You're going to create a table to compare the type of bonds in metalloids to those in metals and nonmetals. So you might want to create like a 3-column table here. You can put your metals, your metalloids, and your nonmetals. And we need to explain these differences in terms of localized versus delocalized bonding.